everyone, welcome to Pre-Calculus Lesson 5.1, the unit circle. This is an extremely important thing in pre-calculus. We use the unit circle in many different cases. So it's important to have a really good understanding of it. So let's take a look at what it is. The unit circle is a circle of radius 1 that's centered at the origin. Okay, that means that it's centered around the middle of your coordinate plane and has a radius of 1, meaning it goes through the point 0, 1, 1, 0, negative 1, 0, and 0, negative 1. So it's going to go around and make a small circle right in the center of your graph. Now the equation for a unit circle is x squared plus y squared equals 1. And this is based off of the equation of a circle that we learned in chapter 1. Remember, it was x minus h squared plus y minus k squared equals the radius squared. Well, the radius is 1, so we have 1 squared. And h and k are the center of your circle. Now, in our case, the center is the origin, or the point 0, 0, and that's why they don't show up here. Now, how can you tell if a point is on the unit circle? Basically, you take the values from the point, put it into this equation here, and you simplify and see if it actually does equal 1 when you add them together. And to find a missing x or y value in an ordered pair, you put in the one that you're given, so maybe you're given x, you square it, solve for the variable you're not given, and then you could just have to decide on a sign based on a quadrant that they're going to tell you. So they will tell you either that it's in quadrant 1, or that the sign has to be positive, or something like that. They're going to give you a clue that helps you figure it out. So let's take a look at an example. In part A, they asked us to show that the point square root 3 over 3, square root 6 over 3 is on the unit circle. So basically, this just means take this, put it into the equation I just gave you, and simplify. So let me show you my work for that. So what I did is I put the x value here, and I squared it, plus the y value squared equals 1. Now I'll just make sure that when I do add them, I get 1. When you square this, the square root squared will just be whatever's inside the square root, that radicand. Then you do 3 squared is 9. Same thing here. So the square root of 6 squared is just 6, and 3 squared is 9. And 3/9 plus 6/9 is 9/9, which is equal to 1. This is true, so I know that this point is on the unit circle. Now let's take a look at another example. In part B, they said the point P with the square root 3 over 2, comma y is on the unit circle in quadrant 4. Find its y coordinate. So what we would need to do is take this and put it into the equation that I gave and then solve for y. This part here is just helping you decide on a sign later for your answer. So let's see what that work would look like. So what I did is I did the square root of 3 over 2 squared plus y squared equals 1. So I squared this part to get 3 over 4. Again, when you square a square root, the square root symbol disappears and you just keep the radicand. And then it's over 2 squared, which is 4. Then I subtracted 3/4 on both sides, and 1 minus 3/4 is 1/4. Then I did a square root on both sides, so this is plus or minus 1/2. Now, I need to pick between plus or minus. So in quadrant 4, the signs of the y value are negative, and you can do that by picking any point in quadrant 4. And if you remember quadrant 4, the quadrants are labeled, let me just get a line here. Oops, that was a bad line. The quadrants are labeled so that, one more line, there we go. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're down here, and the y values are going to be negative here. So that's why I picked the negative value. Okay, now let's talk about what we call a terminal point. And no, we're not killing the points. It's not the point of death. It's points where an angle stops. Okay. So when you're looking at your unit circle, the angles will open in a counterclockwise direction. So they go up through quadrant 1 to quadrant 2, then 3, then 4. Now you can have angles that are more than 180 degrees, and that's okay. The terminal point is going to be where your angle actually stops on the unit circle. So maybe my angle came out like this. This point where it touches the unit circle is the terminal point. And if you're given a negative angle, it will open in a clockwise direction. So it'll start here at the positive x-axis and open in this direction. The positive x-axis is always your starting point for making an angle on the unit circle. Now, we're using a different unit to measure the angles. We're using radian measures. Now, you're used to degrees, and that's what we use a lot in geometry. But radian measures are based off of a full circle being 2 pi. And that is the actual circumference of the unit circle. Because remember, to find the circumference, it's 2 pi times the radius. And the radius of the unit circle is 1. So it's based off of the circumference of this unit circle. Okay, so we measure radians and we say, well, pi, which is half of the full circumference, would be right here on my unit circle. Okay, so this would be an angle of pi would take me right to this point. Okay, let's take a look at an example, and I think everything will become clear to you. In example 2, it says to find the terminal point on the unit circle determined by each given real number t. Now these t values are actually angle measurements given in radians. So what we're going to do is we're going to take the angle they gave, we're actually going to find it. So notice 3 pi. So if I head in this direction, I get to 1 pi. Here's 1 pi right here. Then I'll keep going. And here's 2 pi right here. And then if I go a little bit more, this is going to be the 3rd pi right here. So my answer is going to be -1, 0. So the answer to part A is the point -1, 0. For part B, they said go -pi radians. So that means I'm starting here and going backwards by pi. Now remember, pi is half the unit circle. If I go backwards by pi, I'll end up right here again. So this is the terminal point for -pi. It's also -1, 0. In part C, they said go backwards by pi over 2. Now pi over 2 is 1/4 of the circle right here. So to go backwards by 1/4 of a circle would take me right here. My terminal point is 0, -1. So that is my answer, 0, -1. Okay, next they said go backwards by pi over 4. Notice pi over 4 is right here. It's halfway between 0 and pi over 2. So to go backwards by pi over 4 would take me right here to 7 pi over 4. That would be this point right here, square root 2 over 2, comma, negative square root 2 over 2. Okay, so this is my terminal point, square root 2 over 2, negative square root 2 over 2. Next, they gave me 3 pi over 4. So again, I'm just going to start here and find the 3 pi over 4. That's right here. So this is my result, which is almost this one. So I'm just going to use this one and put it down here and just change the signs. This was negative, and this is now positive. Okay, so that is my point. Finally, they wanted -5 pi over 6. Now this one's really hard because it's not really a quarter turn, it's not like an eighth of a turn, but it's 5 pi over 6 right here. So notice how it's almost like a mirror image from the top to the bottom. The 5 pi over 6, and if you want, you can count the points along the outside. It goes 1, 2, 3, 4, 5, 6, 7 points along the outside. So I'm going to go 7 points backwards. 1, 2, 3, 4, 5, 6, 7. That takes me right to this point, and that's my answer. So my answer is negative square root 3 over 2, -1/2. Next, we're going to talk about what a reference number is. Reference numbers describe how far a terminal point is from the x-axis. Now, in this case, for reference numbers, we're using all of the radian measures here. And all you do is you find the nearest x-axis value and subtract your radian measure from it, and then make your answer positive. So for example, maybe I was given 11 pi over 6, and the nearest x-axis is here at 2 pi. Notice it's marked as 0, but this is also 2 pi. So all I would do is 2 pi minus 11 pi over 6, get common denominators, and subtract. And you would get pi over 6. Okay, now always make sure that your answer is positive. For example, if I was using pi over 6 here, the nearest x-axis is right here at 0 this time because we're closer, we're on the top half of our circle. Okay, and I would just do 0 minus pi over 6, which is negative pi over 6, and then I'd make it positive. Just so you know, in these two quadrants over here, you would be subtracting with pi. Pi is the only value that this point could have unless you've gone around the circle more than once. So let me show you some examples of this. In example 3, they've given us 3 different values they want us to use as reference to find reference numbers. So the first one they gave is 5 pi over 6, which is right here. Notice the closest x-axis value is this pi. So I'm going to do pi minus 5 pi over 6, then make sure my answer is positive. So when I did pi minus 5 pi over 6, common denominators would be 6 pi over 6. 6 minus 5 is 1 pi over 6. Okay, and this is why I said at the very beginning of the year that knowing your fractions was really important because there's a lot of fraction work in this chapter. My final answer here is pi over 6. For the next one, I was given 7 pi over 4. So I'll find that on my unit circle, which is right here. And then I'm going to find the closest x-axis, which is right here, at 2 pi. So I'm going to do 2 pi minus 7 pi over 4. So what I did, 2 pi minus 7 pi over 4, you'd get common denominators. That makes this 8 pi over 4. And 8 minus 7 is 1. This is 1 pi over 4. This is positive, so I can just keep it. Next, we had negative 2 pi over 3. Now, 2 pi over 3 is 1, 2, 3, 4, 5 dots along the top of my circle. So I'm going to go 5 dots along the bottom. 1, 2, 3, 4, 5. So I'm really using 4 pi over 3, which is closest to pi. So I'll do pi minus 4 pi over 3. The common denominator here would be 3. So this would be 3 pi over 3 minus 4 pi over 3, which is negative pi over 3. But remember, the answer always has to be positive. So I make it positive, and that's my answer. Last but not least, I have 5.80. Now notice, that is not anything close to any of the radian measurements on my unit circle. So what I would do is actually find decimal equivalents. So pi, I know, is 3.14. 3 pi over 2, in a calculator, it tells me that 3 pi divided by 2 is 4.7, okay? And 5.8 is more than that. And 2 pi, according to my calculator, is 6.28. So 5.80 is going to be somewhere in this area over here. So all I need to do is subtract it with the 2 pi. And this can be done right in a calculator. And I would just do 2 pi minus this number. Okay, and when I did that in a calculator, I got approximately 4.83. And again, you'd want to make sure it's positive. Okay, so that's it for this video. There's going to be another short video with your last 2 examples on it, so don't forget to watch it.